Hello everybody, I am Nirmal Bhatt. Today I will be talking to you about the concept of matter and antimatter. But what if there was another me? It would be similar to an evil twin, but not quite. It will be another Nirmal, just like me, that talks like me, walks like me, and is same in every other way, except for one. He would be made of antimatter, whereas I am made of matter. We would be really great friends, until we decided to bump fists. If we did, that would result in an explosion which would annihilate both of us, along with the entire Earth. So, what is antimatter? Antimatter is the exact opposite of matter. It's like 2 and negative 2, hot and cold. It has everything similar to that of matter, except for its charge. In order to understand antimatter, one must first understand matter. Matter is composed of atoms, which are further divided into subatomic particles, such as neutrons, electrons, and protons. Neutrons and protons form the nucleus of the atom, with the former having no charge and the latter having a positive charge. Electrons, on the other hand, orbit the nucleus and have a negative charge. These subatomic particles are further composed of quarks. Quarks are the fundamental building blocks of protons, neutrons, and electrons. Everything that you see around you is made of matter, which is made of atoms, and which are essentially made of quarks. Now, let's think about antimatter. It's made of antiparticles, which are the opposite of particles, and similarly, antiquarks, which are the exact opposite of quarks. What is the difference, you ask? Well, the difference here is that instead of negatively charged electrons orbiting a positively charged nucleus in a regular atom, there are positively charged positrons orbiting a negatively charged nucleus in an anti-atom. You might be thinking now, whoa. Okay, so let's slow down here a bit. Positrons are the antiparticles of electrons and have the same mass but different charges. The same goes for any other kind of antiparticle and particle. You have antiprotons for protons, antineutrons for neutrons, antiquarks for quarks, and so on. The existence of antimatter was first predicted by physicist Paul Dirac in his papers published in 1928. His equations accounted for a positive energy solution, a counterpart to the negative energy electron. After Dirac confirmed that the particle that he had predicted could not be a proton due to the proton's greater mass, he predicted the existence of a new particle with the same mass of the electron, but with the opposite charge, which he named the anti-electron. The Big Bang was the explosion that brought about the birth of our universe. Now, scientists believe that when the Big Bang occurred, equal amounts of matter and antimatter were created. As soon as they came into existence, they made contact with each other and blew themselves into oblivion. There's only one problem with that explanation. That never happened. You and I are perfect examples of how what science thinks should happen and what actually ends up happening are two completely different things. So, what happened during the Big Bang? And why is there more matter in the universe than there is antimatter? And why can't we see it? Well, to be honest, I can't answer that question, and nor can any other scientist, because they are still studying and trying to answer the question about the missing antimatter. So, if not much antimatter was created in the Big Bang, then how do we know about it? Well, it turns out that antimatter can be created naturally in a number of ways. First, antimatter can be created through beta decay. Second, through cosmic rays. Or third, through thunderstorms. Antimatter can also be created artificially. Einstein's famous equation, E equals mc squared, states that energy equals mass times the speed of light squared. This essentially means that energy and mass are interchangeable. We use this equation to create high energy collisions of particles in particle accelerators to create antimatter. Antimatter is a very interesting topic to study, but there are many barriers that are blocking our way into the research of antimatter. One of them is cost. Cost is a major player in the study of antimatter. Since scientists haven't found an abundant source of antimatter that they can study, it is up to scientists to make antimatter artificially here on Earth. This costs about $250 million for every 10 milligrams of antimatter that is created. In 1999, NASA estimated that it would take about $62.5 trillion to make 1 gram of antihydrogen. This kind of funding is not available to these scientists. Adding to the problem of cost are the problems of time and energy, because it takes immense amounts of time in order to make antimatter particles. An antimatter particle is not built in a day. Also, the energy that is given back after the annihilation of the antimatter particle in matter is not enough to compensate for the energy that is used into making the particle. Therefore, it is a lose-lose situation for the scientists that are trying to study antimatter. The list of problems doesn't end over there, and the last and final problem that these scientists face while studying antimatter is, in my words, called the containment paradox. In order for scientists to study antimatter, they must first sustain it for a long amount of time. And they cannot put antimatter in a container that is made of matter, otherwise they would both collide and annihilate, leaving you with just matter. Therefore, in order for scientists to study matter and be able to sustain it for a long amount of time, they must create more antimatter in order to sustain antimatter. But even if they somehow got past that paradox, they would have to use equipment that is made out of antimatter on a planet that is full of matter in order to study the antimatter. Because if matter comes in contact with antimatter, we all know what happens. They annihilate. It's like 2 and negative 2. When they meet together, it becomes 0. There is nothing left for us to study. Research to overcome these hurdles is currently in progress, but it will take scientists many more years in order to overcome these problems and fully understand the capabilities and uses of antimatter. Let's hope that that day comes soon. But until next time, whenever you meet your alter ego, you can make friends with them, talk to them, but don't get too close, or else you might regret it. But in the end, just remember this: if it doesn't matter, it antimatters. I would like to thank you, the viewers, who used your precious time to watch my video. I sincerely hope that I have given you an understanding of matter and antimatter. This video was directed by Nirmal Bhatt. It was written by Nirmal Bhatt, and it had creative inputs from Arjun Menon Jayakumar, my friend, and Jigar Bhatt, my younger brother. Thank you all for watching. See you next time.